So good morning and welcome to day 2 of AIAA's Virtual Aviation Forum. It's an exciting day to be here because this morning we're going to be learning all about NASA's role in the newest advances in aircraft and airspace management technology. So I'm Ed Waggoner. My day job is the Deputy Associate Administrator for Programs for NASA Aeronautics. And for the past several months, I've served as the chair planning the Forum 360 portion of this conference. I've thoroughly enjoyed being part of this year's Executive Steering Committee. This virtual conference is truly a historic event, but we know that many of our students in attendance are missing getting to meet the companies and company representatives in person, especially the Meet the Employer events. So the AIAA is excited to announce the AIAA Virtual Recruitment Series. This is designed to connect student members with AIAA corporate members. Northrop Grumman will be chatting with students online today, and tomorrow the students can connect with Lockheed Martin. Aviation 2020 has more than 800 technical presentations and somewhere around 200 technical sessions covering 20+ technical disciplines. The technical advancements being discussed are crucial to our industry and to the world. So join throughout the day to hear live question and answers for these technical sessions. You can find the times and the links under the technical presentations or schedule tab. This morning, it's indeed my pleasure to start off by first recognizing 3 Technical Excellence Award winners. Nadine Albury from Tufts University won the 2020 AIAA Fluid Dynamics Award for outstanding contributions to the reduced order modeling of turbulent flows and to microfluidics. She'll also be presenting the Fluid Dynamics Award lecture today at 12:45. And then George Green, retired Federal Aviation employee, won the 2020 AIAA Low-C Atmospheric Sciences Award for his outstanding contributions in leadership applied to the fundamental of understanding of aircraft weight turbulence. And Udo Years, micro drones. He won the 2020 AIAA Aircraft Design Award for being the father of the modern quadcopter, working for more than 20 years designing, testing, improving these premier aircraft. And we also want to note that the CEAS Aeroacoustic Awards lecture will be presented today by Christophe Bailey from the École Centrale de Lyon today at 12:45. So for these lectures, you can find more information in the special sections tab in the website. But we want to congratulate all of our honorees. Also, as a reminder, the Forum's resources page is your friend this week. This gives you information about navigating the virtual environment that we find ourselves in. As the Aviation 2020 Executive Committee began planning the plenaries and the Forum 360s of the week, there was one individual from whom we all wanted to hear, NASA's Administrator, Jim Bridenstine. Needless to say, we were all ecstatic when the Administrator was able to confirm his availability for this morning's plenary session. Before we hear from Jim, I'd also like to introduce Graham Ward. He's the Technology Executive Director for Aviation Week and Space Technology. Graham will be joining Jim after his remarks to moderate the audience question and answer period. Be sure to submit your questions via the chat feature to the right of your viewing screen. In 2012, Jim Bridenstine was elected to the U.S. House of Representatives, representing the 1st District of the state of Oklahoma. Then, after being elected for a 3rd term, and one that I understand was his promise to his constituencies as his last term, the White House announced on September the 1st, 2017, that Jim was the president's pick to lead NASA. Jim was confirmed by the Senate on April 19, 2018, and he became the first member of Congress to lead the NASA Aeronautics and Space Administration. Jim is eminently qualified. He's one of us. He's a decorated naval aviator, having flown F-18 Hornets and E-2C Hawkeyes. He's incredibly quick study, and he's already demonstrated his keen leadership and a deep understanding of our agency. Jim Bridenstine was built for the tough job of running NASA. And he's a truly brilliant guy. He's got an undergraduate degree from Rice, specializing in business economics and psychology, and he tops that off with an MBA from Cornell. And Jim's 3 terms in Congress have taught him how this town of Washington, D.C. works and how to get things done. Jim's leadership has already earned the respect and enthusiastic backing of NASA's most trusted and progressive managers, engineers, and scientists, which all of you know is no small feat. These are the same men and women who have grown somewhat tired of endlessly fighting to achieve more with less, and eager for leadership that can handle the agency's fundamental economic and management challenges. They're all aware that while in Congress and as a member of the House Science and Technology Committee, Jim focused on building an effective private space economy supported by properly funded government sector. And we were all in awe and buoyed by the success of the NASA SpaceX Demo 2 mission. And it goes without saying that Jim truly understands aviation and is an enthusiastic advocate for the nation's aeronautics community. Jim's tireless. The week he was confirmed in the Senate, I was going on travel, and after arriving home the night before I was to leave, I had a last-minute itinerary change, which often happens. I hustled back down to the office, going into work after the traffic had settled down to pick up a document I needed. I arrived around 8 o'clock, found a parking space in front of our west lobby, and went into the building. As I'm walking in, I noticed a somewhat familiar face leaving headquarters. And I kept thinking, who was that man? Well, it was our newly confirmed administrator. First week on the job, already putting in long hours to understand our agency. And from my perspective, best of all, Jim Bridenstine is an ambassador for space, an ambassador for aeronautics, but most of all, an ambassador for me and for you, the American taxpayer. An ambassador who intimately understands the importance of leadership in space and aeronautics for our nation's future. So today, the second day of this historic AIAA Aviation Conference, it's an incredible honor to introduce to you our keynote speaker this morning, a leader who truly has the right stuff. Please welcome NASA's 13th Administrator, the Honorable Jim Bridenstine. Jim.
Well, I want to thank Ed for that amazing introduction. That was very nice, and I appreciate it so much. People need to know Ed Waggoner is himself a great ambassador for NASA. He has a very tough job, and that is taking some of the ideas that NASA leadership determines are appropriate to advance, and then turning them into no-kidding programs that actually result in something that the American aerospace industry can rely on, and then of course implement into their own capabilities. So I just want to say, Ed, thank you for that great introduction, and it's great to be with AIAA. This is an organization that is committed to seeing the American aeronautics and aerospace industry advance aeronautics and astronautics. And as the NASA administrator, it was an honor to be invited to come and speak to this group, and what an opportunity. Obviously, we're doing this different than any of us wanted to do it. Here I am in my living room, and of course, we're in the middle of the coronavirus pandemic, and so we're all doing this from our houses. Maybe some of us are at work, socially distancing, and doing all of the things necessary to stay safe. But of course, this is not how we wanted to do the AIAA Aviation Forum, but this is the reality we live in. And it's also true that this coronavirus pandemic has wreaked havoc on the aviation industry. I was looking at some numbers last night. Over half of the U.S. fleet is now grounded. That's an astonishing development. I'm at my home in Tulsa, Oklahoma. I went out to the Tulsa International Airport. That's the home of the American Airlines maintenance base. And it is just, they have turned entire runways into parking lots for commercial airliners. So this has been a real challenge for our nation, but it's not just the airliners that are having challenges. And of course, some of the other data I was reading indicated that the airline industry, some of those companies, on average, they're burning about $7 billion a month at this point, which means there's a lot of debt that's accumulating, which is a big challenge for the industry. And of course, the big challenge that NASA contends with is the research and development budgets of not just the airlines, but all of the original equipment manufacturers for those airlines. R&D is the lifeblood of making sure that the United States of America remains preeminent in aviation, which is critically important to our balance of payments, our trade deficit. A lot of you are familiar that I have a boss that talks about the trade deficit a lot. Well, there's one area where, the United States of America has a trade surplus that is greater than any other area, and that, of course, is aviation. And so for our country. So I'll just talk about what some of the programs are that we're implementing on the aviation side. A lot of people forget that the first A in NASA is for aeronautics. And that's understandable because we're doing stunning things in space all the time. We're flying astronauts all the time on the International Space Station. And we just launched Demo 2, which of course was a SpaceX Falcon 9 rocket with a Crew Dragon on the top. $3.5 billion of investment by the American taxpayer through NASA to achieve that end state. And now we're putting together a moon program. We call it Artemis. We're sending not just the next man, but the first woman to the South Pole of the moon. And we're doing it with an intention to go to Mars. Mars is the destination. The moon is the proving ground. So a lot of times in that environment, people forget that NASA is, in fact, about aviation. And aviation is that's our founding. NASA. So let's just talk about some of the programs. We believe at NASA, I believe, that the biggest thing we can do to advance American aviation and, in fact, create the export market that improves the balance of payments, improves the trade deficit, which, again, in aviation, we don't have a deficit, we have a surplus. We ultimately have to have more efficient aircraft. We need to be able to fly to destinations consuming less fuel, emitting fewer carbon emissions, and doing it quieter than the competition. And that requires investment in research and development. And I will tell you, in the coronavirus pandemic, the one thing that has me the most concerned is not just that R&D would be cut by government, but R&D would be cut by our industry partners. Remember, when we advance as a nation, the way NASA does it, we do it with public-private partnerships with our industry partners. So we need those industry partners to be committed to the same goals that we are committed to. And of course, we're seeing right now that I get questions all the time. Well, is the pandemic and the amount of spending happening by the government right now, is that going to reduce, the NASA budget or the aeronautics budget? I will tell you, I don't see that being the case at all. Right now, what we're seeing is a lot of support. We're talking about government spending to make sure that we get through this pandemic. And I think it's been positive. I'm not going to tell you it hasn't been difficult, but I think that the government has been doing the right thing in this very difficult time. And of course, we need to see our industry partners do likewise. So we think about what we need to do on the commercial aviation side of things. We need to have more electric architectures in our aircraft. And so investing in the capabilities so that small aircraft could be purely electric aircraft, larger aircraft will need some kind of hybrid architectures, and doing the R&D necessary to get those more electric architectures for propulsion in our aircraft is critically important to making sure that the United States of America remains preeminent in aviation. So I think that's the highest priority. But the key is also getting more efficiency with traditional aircraft engines. And so when we talk about having a small core in an engine, remember, if we want more efficiency out of our engines, we got to get a higher bypass ratio. The challenge with higher bypass ratios, you get that fan bigger, it becomes heavier, it becomes more complex, more difficult from a thermodynamic perspective. Can't make the fans bigger, or if we're limited in how big we can make the fans. Well, we can do that by having a smaller core engine, and then we can get those higher bypass ratios by making the engine core smaller. And in many cases, those smaller core engines can actually deliver more power, which gives us the ability to translate that create electricity and store that electricity. And the goal there, of course, is higher energy density in our ability to store electricity in batteries. So we need more electric architectures. We need a small core engine capability. And then we need really transformational designs of aircraft. So when we think about how do we improve the aerodynamics of the aircraft that we have, one of the things that NASA has been studying for a long time, and we're getting closer to maybe one day having a flight test bed, would be a truss-braced wing structure. So one of the challenges that we have in flight is that if we have a higher aspect ratio, if we can get our wings to be longer, we can actually reduce induced drag. And if you'll have higher parasitic drag, but you'll reduce the induced drag, which of course is more than the parasitic drag. And if we can do that, then we can actually get close. We can actually have, transonic flight or close to supersonic flight. We're talking about Mach 0.8. We can get to Mach 0.8 in a much more fuel efficient way. We've seen that already, of course, with tests that we've done at the Ames Research Center with some of our high aspect ratio wing designs that include a truss-braced wing, which would be necessary for those higher aspect ratios. So we talk about electrification of aircraft. We talk about the smaller core engines. We talk about how do we change the airframes themselves to be more efficient. And then made are, how do we take the composites that we know that we're going to have to advance in the future, new designs, new concepts. How do we take those concepts and designs and then put them into actually get to manufacturing in a way that the government, the regulators, the FAA can certify rapidly. And so NASA has made those investments, and it's been very successful. The next big step, of course, is to go beyond that, and to actually do high rate manufacturing, not just how do we get from concept to certification, which of course is one thing, but after certification, how do you certify the entire high rate production capability? That's the next big thing that we need to invest in. So if we do those things, we believe at NASA that we are going to put the United States of America in a position to be very competitive in the global marketplace. And of course, the global marketplace is becoming more fractured as it relates to aviation in general. As was mentioned earlier, we're seeing huge investments in Europe from France and Germany. We're talking about, I think France alone has a 50 and we want to make, maybe not that level of investment, at least at this point, but partnering with the private sector, we certainly can get even beyond that, and that's what we're doing at NASA. So that's kind of where we are with just general commercial airline capabilities. The next thing that I think is important is really how we have transformed air traffic management. A lot of people have seen what we call UTM, Unmanned Aerial Systems Traffic Management, UAS, Air Traffic Management, UTM, that's the acronym. The idea is when you're flying small drones, small unmanned aerial systems, a small vehicle flying through that space with a lot of unmanned aerial systems, how do you alert everybody and then have everybody maneuver in a way that keeps all of the operators safe? And so that's been a big project that NASA has undertaken. And of course, we have come to the point now where we have concluded that project. We did some big demonstrations in Corpus Christi, Texas, and in Reno, Nevada, and demonstrated that we could operate multiple unmanned aerial systems in an airspace that was fairly confined and be able to operate safely using partners. So while the FAA will absolutely be involved as oversight, commercializing it in a way where our commercial partners can actually create the corridors and create the routing and the rerouting and the weather data, so that our systems can maneuver as necessary to avoid weather or to avoid winds. All of these capabilities, these are for small unmanned aerial systems under 400 feet. We call it UTM, Unmanned Aerial Systems Traffic Management. That's been really a very successful program for NASA, and it's resulted in a good number of awards. The next thing beyond that, that's 400 feet and below with small unmanned aerial systems. The next thing is how do we integrate unmanned aerial systems into the national airspace system? And in order to achieve that, we need really two things. We need the ability to detect and avoid other traffic, and we need to make sure that we have command and control and communications continuity, so we never lose a link to the aircraft. And of course, NASA has really advanced those capabilities as well. And the idea is we need to be able to one day fly cargo from Dallas, Texas to Miami, Florida, or from Miami, Florida to New York, unmanned in the national airspace system. And so these are technologies that we're proving out. Now, what NASA data with the FAA, and the whole thing we're trying to do, we call them MOPS, minimal operational performance standards, MOPS. We have to develop what are the minimum operational performance standards that we need to achieve in order to be safe. And so we turn that data over to the FAA, and then the FAA can integrate it into their systems. So we talked about unmanned systems below 400 feet, and now unmanned systems integrated into the National Airspace System. And the next big thing is kind of integrating those two together into what we call advanced air mobility. Some of you probably are familiar with urban air mobility. We're now calling it advanced air mobility because it's not just for urban environments. But ultimately, how do we get And so what we would like to see in the decade ahead is we would like to see a city that would have the ability to have hundreds of urban air mobility or advanced air mobility vehicles flying tens of thousands of missions. Again, it could be package delivery, it could be people, tens of thousands of missions in a given day. And that would be transformational for the aviation industry. And of course, it puts the United States of America in the lead, which of course is NASA's objective. So those are kind of the projects that we're working on from an airspace kind of perspective. And then finally, one of my favorite programs is what we call the low boom flight demonstrator, which is how do we fly from New York to LA in 2 hours instead of 6 hours. And what the low boom flight demonstrator is, it's an X-plane. The purpose of it is to demonstrate that we can actually fly supersonic over land and create a sufficiently low sonic boom that it doesn't disturb the public. The challenge historically, as an F-18 pilot, I might have done this from time to time. When you go fast, faster than the sound barrier, it creates a supersonic crack for the people on the ground, and that crack results in a lot of disturbances. And I can tell you that from firsthand experience. So how do we reduce that supersonic crack to the point where maybe it's just a rumble? And it will transform how we fly across the country. So all of these, I think, are important technologies that aeronautics is advancing at NASA. And we look forward to partnering with commercial industry on all of these in the future. And I'm happy to answer any questions.
Hi, Jim.
Hey, Graham. How are you?
Good. Thanks for that. It's great. Always great to hear people talk about the first A in NASA. I'm a first A guy when it comes to NASA. So I really always like to hear that being talked about. You ended up there talking about X-59. Obviously, NASA's back in the X-plane business, and you have two underway. You have the X-57 electric propulsion, which is a small airplane, and the X-59, which is a big program. So you're learning as you go back in the X-plane business. I know X-57 has been a real learning experience for NASA, and obviously X-59 is a very big program for the Aeronautics Mission Directorate. It's actually, for an X-plane program, it's on a pretty tight schedule. You've got to deliver data to ICAO, and so you've got to get flying, you've got to get that data collected. What's your feeling on how that is going in terms of NASA, regaining that experience and ability to fly, big demonstrator programs? And what does that mean for, the ability for NASA to move on and do the next X-plane after that?
Yeah, no, that's a great point. As you're aware, X-planes cost money, and the faster we can move forward with these projects, the sooner we can get to new projects. And that's always, what we want to be able to do. When we talk, a lot of people don't realize, my favorite airplane growing up was the X-29. Graham, do you remember the X-29?
I have a cutaway drawing of the X-29 on my wall in front of me, my all-time favorite airplane.
Yes. So join the club. So when I was growing up as a kid, I really didn't understand the aerodynamics of it, but I just thought it looked cool. So growing up as a kid in the early 1980s, I actually had a poster of the X-29 on my wall. It's for people who aren't familiar with it, it's a forward swept wing design, and it's a beautiful little airplane. But the challenge with it aerodynamically is because it has a forward swept wing, it is far too complicated for a pilot to be able to fly. It will invert itself in a heartbeat, and the next thing you know, the engine is going forward, and you're upside down. And so the challenge with the X-29, we were at the time trying to prove the value of a forward swept wing, and it's a balance between stability and maneuverability. These are always at odds with each other. If you're going to have a very stable aircraft, you're not going to have a very maneuverable aircraft. If you're going to have a very maneuverable aircraft, you're not going to have a very stable aircraft. Well, the X-29 was trying to, at the time, revolutionize stability and maneuverability. And the way to do it was to create a very unstable aircraft and then incorporate into that aircraft flight control systems that were computerized, so that even though a human wouldn't be able to handle it, the aircraft itself would be able to react fast enough to create stable flight at high speeds, even with a forward swept wing. So what a lot of people don't realize, I hear people say, well, how come that plane never became, it never got put into service? Well, it was never intended to be put into service. It was a flight demonstrator of a whole host of capabilities and technologies, not the least of which was, computerized flight control systems. And of course, those computerized flight control systems were the predecessor to what I was flying with in the F-18 Hornet as a Navy pilot. So a lot of these planes, and of course there's a lot of different technology demonstrations in that vehicle, including composites. One of the things with a forward swept wing, it has to be really, really hard material. And of course, the amount of mass required to create the strength necessary for a forward swept wing, well, it just wasn't a flyable aircraft until we advanced composite capabilities that were also demonstrated in the X-29. So, when I think about my favorite airplanes in history, the X-29 is that. And again, it was never intended to be put into service. It was intended to be a demonstrator of technologies that will revolutionize the way we do flight. And that's exactly what we're doing with the X-57. What are the technologies today that are going to absolutely revolutionize how we do flight? We're not flying the X-57 because we believe one day it's going to be, a vehicle that the masses buy. What we're trying to do is prove the standards, prove the, the minimum operational performance standards of this vehicle, so that we can take those technologies and give it to industry. And that's what this forum is all about, the aviation industry. We want to give it to the industry so that they can take that to the next level, and in fact, move those capabilities forward. So yes, we need to move forward with both the X-57 and the X-59, the low boom flight demonstrator, and we need to get on to the next big thing. And of course, question always is, well, what is that next big thing? I really believe that in the future there is a demonstrator aircraft out there that will help us advance all of the things necessary for the United States of America to remain preeminent in aeronautics for commercial aviation industry. Things like the truss-braced wing, things like more electrical architectures, things like a small core engine. These are things like, different materials. I think there is room in the future for that kind of capability. And to get there, as we prove the concepts that we're currently trying to prove, that will inform those next generation X planes. And so NASA has a history of always building upon the knowledge of the previous. And of course, that's true for spaceflight, but it's also true for aviation. And these X-planes are critical demonstrators for that capability.
So you mentioned, as we've seen, France and also to a certain extent Germany have stepped in to try and fill the gap in industry R&D as industry's been hit by COVID. And as you say, there's quite a lot of money being put on the table in Europe. Sort of first part of this question is what are you hearing from your industry partners? Are you getting any sense of distress? Are they going to be able to continue to be the partner that they've always been? And also, as you pulse the industry, should the US be doing more? Should we be moving ahead and putting more money on the table to keep the R&D going, maybe accelerate some of these R&D that you're talking about?
Yeah, as far as the stress on the industry, without question, the coronavirus pandemic, and we're talking about flight loads that are down 80%. I mean, that's so significant. So 80% passenger reduction compared to where we were in January or February, and when we talk about an 80% passenger reduction, as I said, that results in a grounding of aircraft, which means you've got huge investments that are sitting on the deck, not performing for you. You've got cash flow issues. And of course, when our airlines go through that, the manufacturers for those airlines also go through the same thing. And so, yes, there have been massive layoffs and furloughs. And one of the first things that gets cut, this is so important, and it's not right, but one of the first things that gets cut is R&D. And if we look among our partners, our industry partners right now, R&D budgets have already been cut 30 to 50%, depending on what industry partner we're talking about. That definitely affects NASA. I want to be clear, NASA's budget is not being cut. If you look at how the government has responded to the coronavirus pandemic, the government has responded by increasing spending and increasing lending in order to fill the gap that has been left by the industry sagging. So when the private sector quits spending money, the government has stepped up and said, we will spend money. And so when you look at government spending to fill in the gap while we're getting through the coronavirus pandemic, it has not significantly dropped. In fact, it's gone the absolute other way. So my signal to industry partners right now is, look, we're going to be there. If you partner with NASA, your investment will be sound, because I really believe we are not at risk. But it is important to keep that R&D funding going. We need to use this moment, Graham. I think as an agency, as a nation, we need to use this moment as a leadership opportunity to actually move ahead, and not use it as an opportunity to fall behind. And if you look at, as you mentioned, the investment from France, that's what they're doing. That's what they're intending to do. So it is important for us to maintain those R&D budgets. And yes, we are seeing a lot of industry being affected right now. And I would encourage them to not give up. Now is the time to make the investments for the transformational leap ahead technologies that will keep the United States of America preeminent in aeronautics.
So obviously the pressures are also internal to NASA. I mean, you have a very, very hard deadline in 2024 for the first return to the moon. COVID has also hit your plans there. I mean, the first SLS launch is slipping. You've been criticized by your own internal auditors for the schedule and cost risks in the program. How are you feeling confidence-wise? And can you give us some guarantee that aeronautics will not become a bill payer as we get closer and closer and things get tighter and tighter? That importance of aeronautics will remain there. It will remain a priority with NASA, even when these internal pressures start to build.
Yes. You look at, I don't think aviation will become a bill payer. In fact, I'm very confident that it won't. We look at key members of the House and key members of the Senate that have very important aviation equities in their states and in their districts, and they sit at the chairmanships of the right committees. So I don't see aviation. Look, even if somebody wanted to recommend aviation become a bill payer, it's just not. It's not going to happen. I just don't politically. It couldn't happen at this point. So I don't see that as a big risk. But I will tell you
your level of confidence as you go forward. I mean, how are you feeling?
Yeah. So obviously, you guys probably saw. We launched American astronauts on American rockets from American soil. We did it for the first time since the retirement of the space shuttles back in 2011. So it's been 9 years. And yes, even that program was behind schedule. But we got it done. I'll tell you this, what NASA does is we do stunning achievements. We do things that have never been done before. And yes, sometimes our schedules are off. And of course, the coronavirus pandemic is not helping at all right now. But I'll tell you this, we look at the SLS rocket, the biggest, most powerful rocket ever built. It is now fully developed. The core stage is complete. It's under testing at the Stennis Space Center in Mississippi. The solid rocket motors, the boosters that are going to be on the side, they're complete. The Orion crew capsule, the European service module, all of that is complete. What we need to do is we need to get the core stage tested. We need to get it to Kennedy, and in 2021 we're going to launch a human-rated capsule around the moon for the first time. Since 1972. It's been a long time since we've flown to the moon, but we're going to do that next year. And we've got everything built that we need to have built. We just need to get it assembled at the Kennedy Space Center and, of course, get the core stage tested. But no, I have high confidence that we have the support necessary from bipartisan members of the Congress, House and the Senate. And, of course, we're getting strong budget requests from the administration. Right now, our budget request before the House and the Senate is the highest budget request NASA has ever had in its history in nominal dollars. In real dollars, it falls behind Apollo, but Apollo was a very high watermark. So we're very confident that we're going to have the resources necessary to achieve our programs.
So we'll take some of the questions that have come through here, and this one is actually a perennial; it gets asked every year. But it'd be interesting here. So you talked about X-59. It's one of your favorite programs, but there's always a question as why are we spending money developing a low boom flight demonstrator for supersonic flight, which for some foreseeable future will be for a limited piece of the population who can afford to fly supersonic aircraft? Is it really the right thing to be focusing on when the bulk of commercial aviation is subsonic, low cost? It's just for the people.
Yeah. So remember, one of the things that we have to do is we have to make sure that our balance of payments, in fact, the trade deficit, that we are a net exporter of aviation to the world, and the assessment is there will be a demand for this kind of capability. And so if there is a demand for this capability, we would like the United States of America to have that market. And if we do this right, the United States of America will have that market almost entirely. So I think it's important for the United States to continue to improve its trade surplus. And that's really what that program is all about.
Cool. So there's a question here about advanced air mobility, and it's talking about how big a barrier noise is. But I want to just broaden that out slightly to get you to talk about, how you see NASA's role. I mean, obviously, the commercial industry, the startups are moving really fast, and it's quite difficult for NASA to keep pace with that. We saw that in the early days of the drone industry. NASA just didn't really quite know how to play in that market. Now, it panned out that you were able to do UTM, which is a tremendous development and a huge enabler for the drone industry. And as you said, you've done this standards development to do with integrating them into the National Airspace System. So when you look at advanced air mobility, where do you see the critical pieces that NASA can bring to the table to again help build that as a global capability, but a U.S. industry speciality?
Yeah, it's an important question. So when we think about advanced air mobility, You're absolutely right. This is taking so many different directions, and there's so many different designs and ideas and concepts. NASA doesn't want to get involved in that specifically. What we want to do is we want to partner with industry in a way where we can advance capabilities that industry can then benefit from. That's why the public-private partnership concept is so important, and why what so many of our technologies that we do develop that we keep ourselves, we've got to figure out how to take that intellectual property and get it out there, whether it's through licensing or other capabilities to make sure that the technology is available to industry and to the public. So I do think, our goal is not to be able to predict the market and stay in front of it, figure out what direction it's going to go and then lead it. That's not our goal. Our goal is to partner with industry in meaningful ways that enable the private sector to continue to make these advancements. Because you're right, if we're trying to make that market, we're not smart enough to know what direction it's going to go. At least I'm not smart enough. But there are companies out there that are going to end up, moving ahead. And when they do, we're interested in making sure that they're successful. We don't want to create the market. We want to enable the market.
How successfully are you? Is NASA being in engaging the startups? I know that you've internally to NASA, you've done some changes to try and have more of a sort of a kind of a startup culture within NASA, and I know that as a result of that, you have reached out to some of these new players. I mean, obviously, the longest relationship that NASA has with industry is with the big established players, but we're seeing a great broadening of the industry base going on at the moment. And how well is NASA being able to engage that, as you say, transfer technology to that, not just market enabling, but just getting technology out and helping those startups?
Yeah, so we have a number of programs that are designed specifically for that, and those programs do in fact have a lot of support from our representatives in the House and the Senate. So small business innovation and research contracts. So if you're a small company out there and you're developing a capability that would be absolutely transformational, and it's early in the technology development, that's what that small business innovation and research contract is all about. The idea is, if we can help you get that technology sufficiently mature that it becomes commercializable, then we have all won. So we do have very specific programs for that, and then of course we've got our technology transfer capabilities, where when NASA does its own research, which we do from time to time, we can patent that research and then make it available to the public through licenses. Those are the ways that we engage a lot of those startup kind of companies.
Are you seeing that type of culture come within NASA? Are you seeing that the NASA researchers themselves are taking a more entrepreneurial approach internally?
Well, absolutely. Again, the idea is, we want those small entrepreneurial companies to be successful, and so if we can partner with those companies in a way that's meaningful, then we do that. It's not unlike what we've done with SpaceX and Boeing when it comes to commercial resupply and commercial crew. Northrop Grumman, for example, with commercial resupply, we become the customer. And by becoming the customer, they make big investments. Well, with SBIR, Small Business Innovation and Research, we want to support those kind of companies in advancing their very unique and important technologies. And they're not all going to be successful. I think that's an important thing. That's what SBIR gives us. A lot of times we can do grants and things that, we get criticized if we invest in something and then it fails. And that happens, but that is part of that culture. A couple of years ago, in fact, about a year and a couple months ago, the vice president gave a speech down in Huntsville, Alabama, at the Marshall Space Flight Center, and he encouraged us. He said, "Fail, but fail quickly. You got to fail quickly and then move on." And that's how you continue to advance. So. We should not be afraid of failure. What we should be afraid of is making bad decisions. And a lot of times you have to have failures in order to get to those successes.
So you mentioned electrification in your presentation, and one of the questions is, what about, and you talked about small core as well, so we're not forgetting the turbine side of things. But obviously, one of the questions is about other types of propulsion, and interestingly enough, obviously in Europe at the moment, there's a big increase in interest in hydrogen, which if you're as old as I am, goes back a long way in aviation. This interest in hydrogen as a propulsion source. Is it something that as you ramp up the electrification work, are you keeping your aperture open to say whether, you know, I mean, hydrogen or something like that might be a better approach? Fuel cells, I don't know whether.
Yeah, I think it's definitely something that we're looking at. It's definitely a capability that we are interested in and continue to monitor. We don't have big investments necessarily into hydrogen right now, but that's not to say that we couldn't do it in the future if it looked promising.
So we're going to go back here to you talked about commercial, you know, and you talked about, I mean, the great Demo 2 launch, and then when you look at your sort of the Artemis program, there's a great deal of, you know, commercial launch vehicles that play a large part in that, getting pieces of the architecture into space. So on one level, it seems like a great investment. It's so far been a great success, but I mean, are there not risks? We've just had a pretty high profile bankruptcy in the commercial space, OneWeb. You know, I mean, do you worry about? Is there some sort of, how much do you worry about that? And is there something you can do to kind of backstop that risk?
Yeah, so that's actually a very important point, and it is absolutely true. We have seen, we have seen efforts where NASA makes investments and then companies go bankrupt, and then NASA's just left hanging with millions of dollars worth of investment out there. That happens from time to time. I will tell you that when we think about bankruptcy law in the United States of America, very rarely does a firm just fold up and go away. What ends up happening in general is that basically the shareholders of the firm, they get diluted, or maybe they get wiped out altogether. At the end of the day, the firm will continue to move forward. It will just continue to move forward with different ownership. And so I think that has proven to be the case over time. But if we are making investments in a company that just folds up and goes away, that's a problem. Generally, that's not been the case. Generally, it moves forward. It just goes forward under different ownership and different management. And of course, the shareholders are the ones that get hurt. But NASA's investments and the technology that comes from it usually move forward in a good and meaningful way.
So the very first question you got is it's very deep. Sounds like a very deep in the weeds question, but it actually has an interesting angle to it. And the question was, there are certain technologies, in this case it's active flow control, where there's a lot of research going on. There's a lot of breakthroughs being claimed, a lot of performance claims being made, but there's no sort of there's no good housekeeping or litmus test of these technologies. And this was specifically about active flow control, but I also wonder whether or not NASA plays a role with the speed at which some of these technologies out there are moving. Is there a role for NASA to be that sort of that expert vetting, to sort of try to sort of bring some reality to some of these technologies and ground people in what is real and what isn't real?
Absolutely. I mean, that's it's a double-edged sword. In some ways, yes, NASA is the expert, and NASA can help people move along, help private companies move along and go faster than they would otherwise go. In other areas, NASA is following the leader because private companies can innovate in ways that we're not even thinking about. I'll just give you an example, and I know it goes back to space, and this is the Aviation Forum. But we look at what happened just a few weeks ago with the SpaceX Falcon 9 rocket with the Dragon crew capsule at the top and American astronauts inside. In that launch that went to the International Space Station, there was a lot of unique capabilities embedded in that rocket that NASA would have not been comfortable with years ago. Things like supercooled liquid oxygen. The idea that you would put composite overwrap pressure vessels inside a liquid oxygen tank. The idea that you would launch a rocket with 9 engines. The idea that you would bring that rocket back and land it on a barge in the middle of the ocean. You know, these are all concepts that if NASA would have done it internally, never would have happened, because NASA would have said it's too dangerous, there's too much risk. Well, a private company comes along, they make their own investments, NASA invests side by side with it, and all of a sudden there's a partnership here that results in transformational changes. And I will tell you, NASA, a lot of people at NASA thought it couldn't be done, that it shouldn't be done. But over the course of time, through the engineering demonstrations and the testing, NASA started to become very, very comfortable. In fact, started acknowledging that this is actually, with a launch abort capability, this could very well be the safest rocket ever designed in theory. Of course, we've only had one human spaceflight so far, and that human spaceflight is still underway. I'm knocking on wood because we need to bring them home safely. But right now they're doing great work on the International Space Station. But you see my point. My point is, in some ways, NASA was the engineering expertise on a whole host of elements on that rocket. And SpaceX desperately needed what NASA was helping them with. In other areas, NASA was saying, we don't really feel comfortable with this, but we'll let you keep going until we see something that's problematic. And through testing and evaluation and integration, we got to the point where we're very comfortable. So it's both, Graham. I will tell you, it is both. It's NASA in some ways leads and helps move faster, and in other ways, NASA has to put the brakes on and say this isn't going to work. And in that case, look, one of the things that I hear Jeff Bezos say frequently, he says, slow is smooth and smooth is fast. And sometimes NASA needs to be that check to make sure that things aren't getting too rapidly out of control.
So we're going to wrap up here, but people like to sort of jokingly say that the aeronautics budget is kind of a rounding error within the overall NASA budget. But what can you just wrap up? I mean, it sounds like you're saying it is in a good place, that it's doing good work and producing good results.
Absolutely, I would say yes. It's small. It's $700 million, which compared to the $22 billion budget that is NASA, it's a small percentage of the overall budget. But again, it's what you use that budget for, and it's the public-private partnerships that matter. And yes, it's not the biggest part of NASA, but it's not shrinking. And I will tell you, the administration and bipartisan members of Congress understand how important aviation is to the American economy, and they're very, very committed to seeing it be successful. And NASA is a big part of that. But we're also not the only government agency that invests in aviation. Obviously, if you look at the amount of investment coming from the Department of Defense and DARPA and the Air Force, there's the FAA. There's a lot of investment that's important that goes well beyond NASA. But what NASA tries to do is those very cutting edge, leap ahead kind of developments in technology, and we've been doing that for many years, and we do it on the commercial side, not on the defense side. But a lot of those technologies, as you know, go back and forth.
Well, thank you, Jim, and the first A in NASA thanks you as well, I promise. You've given us a lot to think about, and we've only just beginning this AIAA Aviation Conference. So again, thank you very much. So thank you, Jim. So anyway, folks, please tune in for the morning Forum 360 session at 9:30 Eastern Time, where you'll learn more about NASA aeronautics, the real deep stuff, and how technology advances are enabling breakthroughs in speed of aircraft and the efficiency of transport aircraft. And as Jim has told us, opening up new markets for small aircraft, whether it's urban or regional or these new types of advanced mobility. And then, of course, there's all the new drone applications that NASA's been enabling through UTM and other programs. So this afternoon, you'll learn about the grand challenges for aerospace computational fluid dynamics capabilities outlined in the CFD 2030 roadmap, which is surprisingly interesting, I can promise you, during the Forum 360. that CFD is going to transform how we design aeroplanes. Remember, you can watch these sessions on demand or live. And don't forget to check out the Hub, which is sponsored by ClickBond, for programming and networking opportunities throughout the day, including a technical networking session today at 5:30 to 6:30 Eastern Time. So now it's time to grab a coffee or your favorite morning beverage. Hopefully there'll be less of a queue than if you're at the Aviation Forum in person. You can still use the same chat feature you've been using to put in questions. You can use it to say hello to old friends and make new ones while you enjoy your coffee break and get ready for the next session. And finally, I'm going to do this. Also consider us showing us who you're working with. Do you have a pet keeping you company during the virtual AIAA Aviation Forum? You can use hashtag AIAA Aviation and post a pic. So I have 3 cats up here. They were banned from my office while we were doing this, but they're waiting outside to see me. So thank you and have a great rest of your day.